There is non-uniformity in the velocity distribution in an open channel cross-section. This produces a true velocity head which is somewhat greater than the velocity head calculated based on the mean velocity. The true velocity head is in which alpha is the energy or Coriolis coefficient, v sub m is the mean velocity, and g is the gravitational acceleration. Typically, alpha varies in the range 1.03 to 1.36 for fairly straight prismatic channels. Alpha is larger for smaller channels and smaller for larger channels. As in the case of energy, the true momentum flux is somewhat greater than the momentum flux calculated based on the mean velocity. The true momentum flux is in which beta is the momentum or Boussinesq coefficient, rho is the density of water, and Q is the discharge. Typically, beta varies in the range 1.01 to 1.12 for fairly straight prismatic channels. Alpha is always greater than beta. In channels of complex cross-section, alpha and beta can attain values of 1.6 and 1.2 respectively. Values of alpha greater than 2 have been observed in very irregular cross-sections. Assume A equal total area of the cross-section, V sub m equal mean velocity of the cross-section, delta A equal incremental area, V equal velocity through the incremental area. The total volumetric flux or discharge is the total weight flux is in which gamma is the unit weight of water. The incremental weight flux is the kinetic energy is equal to force times distance, that is, mass times acceleration times distance. It is expressed as follows. In which m is the mass of water. The velocity head is the kinetic energy per unit of weight. The kinetic energy flux is the kinetic energy per unit of weight times the weight flux. That is, the kinetic energy flux is equal to the velocity head times the weight flux. The total kinetic energy flux is likewise, the kinetic energy flux through an incremental area delta A is the total energy flux is equal to the sum of the incremental energy fluxes. Thus, the energy or Coriolis coefficient alpha is the total mass flux is the incremental mass flux is the momentum is equal to force times time, that is, mass times acceleration times time. It is expressed as follows. The momentum flux or force is equal to the mass flux times the velocity. The total momentum flux is equal to the total mass flux times the velocity. The incremental momentum flux, or incremental force, is equal to the incremental mass flux times the velocity. The total force is equal to the sum of the incremental forces. Thus, the momentum or boostiness coefficient beta is the mean velocity is defined as follows. Values of alpha and beta can be approximately estimated with the following relations. In which epsilon is the pressure is measured by the height of the water column at any point in the vertical. Under parallel flow, the streamlines have zero curvature and zero vertical accelerations. Conversely, under curvilinear flow, the streamlines have non-zero curvature and non-zero vertical accelerations. Under parallel flow, the pressure distribution is hydrostatic. That is, the pressure P at any point is proportional to the flow depth h at that point. Uniform flow is essentially parallel flow. Gradually varied flow may be approximated as parallel flow. Under curvilinear flow, the pressure distribution is not hydrostatic. Curvilinear flow can be either 1. Convex or 2. Concave. Under convex curvilinear flow, the pressure distribution is less than hydrostatic. Under concave curvilinear flow, the pressure distribution is in excess of hydrostatic. The centrifugal pressure is the mass per unit of area times the centrifugal acceleration. In which r is the radius of curvature of streamlines. The pressure rise C is the rise is positive for concave flow and negative for convex flow. The weight of the shaded element of length dl and width 1 is in terms of depth of flow y, the pressure due to this weight is the pressure head is if theta is small, the factor cosine squared theta will be very close to unity, and the pressure head h will be close to the flow depth y. The correction is less than 1% when theta is less than 6 degrees, that is, when the slope is less than 10%, or 0.1. A channel of slope greater than 0.1 is a channel of large slope. In a channel of large slope with appreciable curvature in the streamlines, the pressure head should be corrected for curvature effects. High flow velocities entrain air, producing volume swell and depth increase.